Hello everyone, I'm back with another video. As I told you that I will divide up the entire algebra into two parts, which is the second part of the algebra. And today I will be covering the important topics and formulas related to inequalities, functions, and complex numbers. So let's start with the inequalities first. In case of inequalities, you get a range of values. So let's talk about the four basic inequalities that you should know. The first one is x greater than a, x greater than equals to a, x less than a, x less than equals to a. So these are the four basic inequalities that you need to know for inequalities. Now, what is the meaning of x greater than a means there is a variable which is x and the values of x is greater than a constant a. A can be any constant, it can be positive, it can be negative. That depends upon the question. So now how to represent it on a number line? Number line, that's very important here. Let's say this is your zero. The right side approaches to the positive infinity, the left side approaches to the negative infinity. Let's say this is your a. So if you want to get the values which are greater than a, then you need to move to this region. I'm making a circle here, and this is the region you want. Now, there is a very slight difference between these two inequalities, x greater than a and x greater than equals to a. So again, the same number line, 0, infinity, minus infinity. This is your a. Now, instead of circle here, you have to make a dot, and then all the values on the right side of the a is included. This is a very slight difference that here a is included, and here a is excluded. Okay, and the range of the values is x belongs to a till infinity, and here x belongs to a to infinity. Here the brackets are here the bracket is closed, which represent the value of a is included, and here the bracket is open. The same kind of approach is in the rest two inequalities. This is your zero, this is your a, this is your infinity, this is your minus infinity. If you want to get the values less than a constant, you have to start towards the left side of it. So all these values are allowed. And on the right side, you have x less than equals to a. So this is 0, this is a, this value is included, and again to the left side. The range of values here is x belongs to minus infinity till a, and here x belongs to minus infinity till a with close bracket. So these are the four basic inequalities you should know about. Now you can add, if you want to add a constant in any of the inequality, you can add it on both the sides. If you want to subtract, you can subtract it from the both the sides. You want to multiply or divide a positive constant on both the sides, you can do it. You have to do all these operations of arithmetic operations or adding, multiplying, dividing, or subtracting a constant. You have to do that on both the sides. There is a slight difference that you need to take care of whenever you are dealing with a negative constant. If you are dealing with negative constant, and you're multiplying and dividing with a negative constant, multiply or divide, then after multiplying or divide the negative constant, you have to change, or you can say the reverse the sign. That is okay. Okay. The next concept of inequality is that if you want to add two inequality, if you want to add two inequalities, then in that case, signs must be exactly same. Like if this is a sign in inequality first, this is the same sign in the inequality second. If this is a sign in the inequality first, this must be the same sign. And in case of subtraction, if you want to subtract two inequalities, then signs must be opposite. Signs must be opposite. If this is a sign in first inequality, that is the sign that sign must be in the second inequality. If this is a sign in first inequality, this is a sign in the second inequality. So those were the concepts, the quick concepts related to inequalities. For the rest of the concepts, you can refer to your notes. Now I'm moving to the functions. Now here comes the function and the first question arises. What do you mean by function? Can I call any given algebraic equation or any given polynomial as a function or not? So the answer is no. You can't call each and every algebraic equation or a polynomial as a function. There is a condition. That condition is that every input value must have single output value. So every input value means the input value is represented by x and the output value is represented by y. So every x value must have a single y values. That is the first definition. This is the basic definition of function. Now, let's understand from an example. Let's say there is a set x and there is a set y. Okay, the values are x1, x2, and x3. Here the values are y1, y2. So for every value of x, there must be only a single value of y. For example, x1 must have y1 as a single value. X2 can have any of the value like y1 and y2, and x3 also can have the value out of y1 and y2. So this is a function. This is a case of function. Second thing is the VLT test. VLT. VLT test is vertical line test. Vertical line test. This test is useful in a case of identifying that the given graph is of a function or not. So what you have to do, you have to draw a vertical line on a given graph. Simply you have to draw a vertical line on a given graph. If vertical line intersects graph more than once, then it's not a function. So again, I'm repeating. You have to draw a graph. So you have to draw a vertical line on the given graph. And if that given graph is intersecting, the given vertical line is intersecting that graph more than once, it will not be. Next concept is of domain. Domain. Domain is collection of, or you can say the set of all input values on which the given function is, on which given function is valid. Now, what is the meaning of valid function? For example, if this is a function fx equals to 1 by x, if this is a function, this is not valid at x equals to 0. Okay, so this is not valid at x equals to 0. So it means you can't take the value of x is equals to 0. For a function like this, your x value cannot be, or the value inside the root cannot be negative. So you can say that your x minus 2 should be greater or equals to 0. It means the value of x should be greater than equals to 2. So how will you write a domain for it? You will write that x belongs to R, or you can, in a simple language, you can say that all the values x belongs to 2 to infinity, which is a domain for second one. And for this, we can say that your x belongs to all real numbers except 0. So that is the case of domain. Second concept is of range. Range is very simple. Range is collection of collection of all the output values. Is collection of all output values. Okay. Next topic is the last one for the algebra is complex numbers. Now, how to represent a complex number? A complex number can be represented by z equals to a plus iota p. This part is the real part of a complex number, and this is the imaginary part. You must be thinking that what is iota? Iota stands for iota stands for root of minus 1. This is the value of iota. And never ever you have to write that I equals to root of minus 1 in your solution. You have to simply represent this value by iota only. Now, there are the powers of iota that you should know about. That iota power 1 is iota itself. Iota power 2 is minus 1. Iota power 3 is minus iota. And iota power 4 is 1. So these are the values of all the basic or the important powers of iota. Other than these four powers, if you have any power like 434, iota power 1010, iota power 646, you can find out the value by dividing it from 4. Dividing the powers from 4, noting down the remainder, and that remainder will replace this power. And then you will be able to find out the value of that remainder value with the iota. Okay, so that is about the powers of iota. Now you can add, if you want to add two complex numbers, you can subtract two complex numbers, you can multiply two complex numbers, but you can't divide two complex numbers. So if you want to add, you want to subtract, you have to add the real part with the real part, and you have to add or subtract the imaginary part with the imaginary part. Okay, so that was about the complex number. So the last three topics were more related to the theoretical part instead of the formula based. So that was all about the algebra.